In this video, we'll start our introduction of the Python programming language. We will start by overviewing the syntax of the language. As any human language, programming languages also have syntax. There are some rules that have to be followed, and there are also some constructs that this languages provide to programmers in order to express ideas and algorithms into code. The basic idea of programming is that we want to provide a set of instructions that the computer can follow in order to convert a certain input to a certain output. Let's start with a very basic example. Let's say we have two numbers, x and y, and we want to add these two numbers. This is a very basic program. We're going to start with x and y. Let's say the value of x is 1 and the value of y is 4. And then we want to add x and y, put the result into z, and at the end of the day we want to see what z is, and the value of z is 5. This is a computer program that has 4 instructions. In the first instruction, we are creating what we call a variable. It's basically a placeholder where we place values. The name of the placeholder is the name of the variable, and the name of the variable here is x. The value we put in x is 1. This value is set in the code. In general, when we read data, we will be getting values from external sources like data files or by interacting with the user. Similarly here, we're putting the value of y to be 4, and then we're creating a third variable z. The value of z is now computed by adding x to y, and at the end, this instruction is basically just printing back the value of z. That's a basic computer program that has 4 instructions. Let's take a look at this example here. In this example is basically trying to separate numbers from 0 to 9 to two lists that of numbers which are less than 5 and a list of numbers which are greater than 5. So what we have here, we have one variable called midpoint, and the value of midpoint is 5. And then we have two variables, lower and upper, and those two variables have a value which is a list. Now, numbers in Python are very much like numbers in mathematics. They're using digits here. List, which stands for a list of things, can be expressed by listing the values into two brackets. This is part of the syntax of the language, and we're having two such lists here, lower and upper. Next, we have something we call a for loop. This for loop goes over numbers from 0 to 9, and those numbers from 0 to 9 are given by this expression range 10. Now within this loop, we are examining each number, and each number is referred to as I. If I is less than midpoint, we are changing the lower list by appending I to it. Again, that's an example of an instruction, but if that's not the case, if I is not less than midpoint, then we're adding it to the upper list. At the end, we are printing lower and the lower list, and upper and the upper list. Now let me go through this program one more time and talk more about the syntax of the language in more details. So you can notice that there are some lines that start with this pound character here. This means that this statement is just a comment. It means it's completely ignored by Python, although it's very useful to add comments to the code. It basically communicates the intention of the programmer, so if someone else is reading the code, they understand what the intention of this statement was. So in this case, it says set the midpoint. Obviously, this is anything. It can be anything. This is just English text, and Python is not going to validate a comment, right? It's completely ignored by the programming language. We also notice something here is that each instruction is put on one separate line. So hitting enter like here is means we're starting a new instruction. This is in contrast to other programming languages such as Java, C++, and other programming languages that ends a statement by having a special character such as a semicolon. This may seem very familiar to you if you are coming to Python from Java or one of C-like languages. We have to end the statement with a semicolon. In Python, the semicolon is optional. Adding it will not change the resulting here, but we don't need to add it. In Python, a new line means a new instruction. So this saves the programmer the effort of putting many semicolons, and as a result, results in a more readable code, more pleasant to read because there are less semicolons. Now here we see that there is a semicolon, which means that if we want to put two instructions on one line, we need to have a semicolon. Thus, the semicolon is needed if we don't want to do each instruction on one line. So I can do two instructions each in one line. But if I want to have the two instructions put side by side in one line, and that's usually the case if there are small instructions and they're conceptually related, I need to have the semicolon. Without a semicolon, this will be invalid syntax. But with a semicolon, this will mean that this is one instruction and this is another instruction. Next, let's take a look at this for loop. And we will get to talk about loops in more details in the future. So we will not be concerned about the specific kind of internal of the loop and what's going on. What I want you to understand in here is that this loop has a set of statements that execute within the loop. And those set of statements are the if and else statement here. And you can notice that this statement belongs to the loop because it's indented. Meaning it has one level of indentation beyond the loop. Without indentation, they will look like something like that. But this is incorrect. We need to indent a piece of code in order to make it belong to another statement, such as a loop in this case. So Python, to be more specific about the technical terms, if you're coming from a different programming language, Python uses white space indentation to indicate scoping. Now, scoping in other languages is indicated by using special characters such as curly brackets. So in Java, we may want to write something like this for I going from 0 to I is less than 10 and then I plus plus. We need to indicate the scope of the for loop using two curly brackets. The curly brackets are mandatory here. I mean, obviously this code will not run here. This is not Python code. But that's not needed in Python. Python uses the white space to indicate scoping. Similarly, in the if-else statement, we have to push this code a level down so that it belongs to the if statement. Now, in practice, this is not an issue because any editor that we use, such as the Python notebook, will do that by default. Once we start, for instance, a for loop, hit enter, it's going to give us this indentation by default. So we will not be worried about hitting space or tab to get to the indentation. But often if we're copying and pasting code, we need to be careful to properly indent it. So for instance, if I want to print I here, let's do that here. And let's say I want to put print I within the loop. So I may, for instance, want to copy and paste. And if I copy and paste it here, it will show out of scope, and actually this will not be valid syntax because it's expecting us to indent the block. So we need to place the cursor here and hit space or just simply tab to properly indent it. That's needed to kind of notice the white space and indentation. Once again, the usage of white space instead of special character like the curly brackets results in a very readable code. There are no semicolon, there are no curly brackets. The code is much more compact and it's easy to follow because of the usage of white space. Let's talk more about the syntax of Python. Now, when we have a mathematical expression, we can group operations using parentheses. So parentheses serves two purposes in Python. They serve to group operations, such as in this code snippet, when I want to multiply 2 by 3 plus 4. Without parentheses, I'm going to multiply 2 plus 3 and then add 4, so I will get 10. But with parentheses, I can specify the order of the operations. So I can go 3 plus 4 and then multiply by 2. Once again, this should be very familiar to us because this is the same conventions that we use in mathematics. Again, whenever I want to execute a code, I either hit run or shift enter. The other purpose that parentheses serve is to pass parameters to functions. So functions are the names of other programs that do work for us without us having to write the code for these programs. One of the functions that we've used above is the print function. Print basically prints whatever you pass to it as parameters. Another function that we have used above, if we take a look, is the function append. Append is a function that changes a list. And we don't need to worry about how this function changes the list. We just use the function and we pass, the new element in the list as a parameter. So parentheses serve to pass parameters to function, and that's the other uses of parentheses in the Python language. Now I want to talk more about variables. So conceptually, we can think about a variable as a placeholder for a value. And that's the case for the variables we have seen above. In this example, we have three variables. Well, we have three values that we are assigning to the same variable x. In the first instance here, we are assigning an integer, a number, to x. In this example, we are assigning a piece of text, which is also called a string, to the variable x. In this example here, we're assigning a list of values to the variable x. Now in each one of these instances, the value of x is changed depending on what we put inside it. A very important point is that the variable as a placeholder for the value actually points to where the value resides in memory. This is a technical detail that 99% of the time we shouldn't be worried about, but it can lead to some weird behavior in some instances. Let's take a look at this example here. I assigned the value, the list 1, 2, 3, to the variable x. And then I assigned the variable x to the variable y. So now if I print y, unsurprisingly, I will get 1, 2, 3. Now, I'm going to change x by appending 4 to x. Now, if I print x, I'm going to get 1, 2, 3, 4, which is not surprising. But if I print y, I'm going also to get 1, 2, 3, 4. And that's because y and x points to the same value. Now, if I don't want them to point to the same value, I need to recreate the value here. If I do something like this, x is equal to 1, 2, 3, and y is equal to 1, 2, 3. Now, if I change x, y will not change, because although they have the same values, it's the same value repeated. So physically speaking, in the computer memory, there are two instances of these values stored. But in this case, there is only one instance. In this instance is been represented in two variables in our code, x and y. Now you may ask the question, so why do we do that? Why is it the case that we represent this, once rather than duplicating it? And the reason is that we would like to be efficient. Imagine if this is a data set that contains thousands of observations. And imagine that every time you're assigning this data set to a new variable, you're copying it. This is very wasteful of computational and storage resources. So a shortcut is just to treat the x and y as what we call pointers or references. You can think about them as addresses. If I give you my address, it's different from my house. Now you can access my house by knowing my address, but that doesn't mean that my address is my house. If I copy my address 5 times, my house is still the same, but I have 5 copies of my address. That's the same concept of a variable as a pointer. Now, fortunately, this doesn't happen with basic numbers. For basic numbers and strings, Python is smart enough to know that it's not a big deal to duplicate these values. So in this case, if you have x equals to 10 and y is equal to x, even if you add 5 to x, the value of y will not change. So I want to qualify this note in here by saying that it doesn't apply for singular values, basic values such as integers, numbers, and strings as well. The last point I would like to make is that in Python everything is an object. Now if you're coming to this course from an object-oriented background such as Java or C++, this should be straightforward. If not, you can think about an object as a special variable that not only it holds values, but it also holds functions that operate on these values. For instance, take a look at this variable x. X is equal to 4. We can know the type of that object by using a function called type. Type x, and it will tell us that x is an integer. Now, x has the value 4, but it has much more than the value. We can access the functions that belong to an object by calling them, and we call them by using the dot operator and then the name of the function. If we don't know the name of the function, we can simply hit tab and we will invoke code completion, and we can see here that we have probably 8 functions and attributes. They may be functions, they may be attributes. Attributes are some values associated with this object. So for instance, the function bit length, it tells me the length of this variable in bits. So I can do this function, call it, I need the parentheses, and this will tell me that the result is 3. An attribute is basically another value associated with this object. Take a look at the real attribute here. It basically gives us the real component of the number. It's an attribute, it's kind of like another value attached to the object. So x equals to 4 is going to create a variable x, and the value of x is 4. But that variable is an object, which means in addition to the value we put in it, it has access to all of the functions and attributes that the integer data type provides. Let's take a look at this example here. X is equal to hello in this case, and the type of x is str for string. It means that we have a variable called x, and this x has a value which is hello, but we have also access to all of the functions or methods of the string class as well as all of the other attributes. Now for the string class, there are many of them, and we will take a look at some of these when we talk about string and text in Python. For instance, let's take a look at this function called upper. This function converts the string from lowercase to uppercase, or from any case to uppercase. So we have access to all of these methods that we can call on the object. Here is another example. This is x equal to 3.14. Type x is float for floating point number, and in addition to the value itself, we can access all of the functions that let's run this cell here, that the float data type provides. For instance, I can convert it to an integer ratio if I wish, and that's an integer ratio that if divided will result in 3.14159. So don't trust me, just divide it and you will get the same number. Now, how does Python figure out the type of a variable? How did it figure out that this variable is a string and this variable is a float and this variable is an integer? It has to do with the value that we initially assign to that variable. The value that we initially assign to the variable will determine its type. There is no need to declare the type of the variable prior to using it. That's called dynamic typing. If you're coming to this course from Java, this is a big difference, because in Java we have to specify the type of our variables, which is called static typing. We need to say, well, variable x is an integer before saying x is equal to 4. Of course, that's not the Python code, it will not run here. But the basic idea here is that in Java we need to specify the type of the variable prior to assigning a value to it. In Python that's not needed. We just assign a value to the variable, and this value will determine the type of the variable. And this means that the type of the variable can change. Type x may be an integer in one place, but if we, for instance, add 0.1 to x, now x is a float because it's no longer 4, it's 4.1. In this example, we have a list, because the value we assigned to L is a list as indicated by the brackets. Here is another example where we have a floating point number and we're accessing attributes because those attributes belong to the float data type. Although the value is 4.5, we can access the real and imaginary part of that value because it's a float value, as well as accessing the other methods or functions that are provided by the float data type.